So, question 3. During the period leading up to the Christmas holidays, P Cubed hires temporary staff. Staff are hired for each of the 6 weeks prior to Christmas week. Okay, so here is the pseudocode for an algorithm that calculates the number of additional staff needed for each week. Okay, so it's really important that you do read that, and as you know, we're now going to read the pseudocode carefully before we look at the question, because even if the first question is just about the programming constructs, later part 3b, 3c may in fact require a much deeper understanding of the pseudocode. So read it at the beginning of the question. Okay, percentage, right, start. Percentage of staff needed in 6 weeks prior to Christmas. Set week number 2. And we have here an array, and it's got strings because we can see the speech marks, and it goes from -6 down to -1. So 6 weeks before Christmas, 5, 4, 3, 2, and 1 week before Christmas. Set staff rates 2, and another array, this time containing integers. 6 weeks before Christmas, we've got 100. We need 105 staff, then 110, then 115, and you can see it's going up by 5 until 1 week before Christmas. They need 130 staff. Set good input to false, so a variable this time rather than an array, and a Boolean data type of false. This is the kind of analysis, the reading that you should be doing and thinking about what you've got. Another comment here to validate the input, so we're now going to check the input, and we have got while good input equals false, which it is, do the following. Please enter the number of staff on week -7 to display. The variable that's going to store that is called current count. Receive current count from integer keyboard, so we're expecting an integer there. If current count is greater than or equal to 200, then set good input to true, which would stop the loop. Send staff on week -7 is current count to display. Otherwise, send invalid input to display. Then we've got our print requirements. So down here we've got a for loop for I from 0 to length week number -1. Let's just take that line. So we can see it's a for loop because it says for, an end for, and this is the code that runs. Now I, so short for index, your loop counter or your position in the loop, so we'd expect I is always a number, from 0 to length of week number. Now length we know is a function that returns a number according to the number of elements in a list or the number of characters in a string. Week number is our list here, our array here. 1, 2, 3, 4, 5, 6. 6 elements in that list. So for I from 0 to 6 minus 1, so from 0 to 5. Why is it 0 to 5? Well, because the computer will start counting at 0. 0, 1, 2, 3, 4, 5 gives you 6 loops. So this loop is going to run 6 times, so it's going to loop or iterate through the list. In fact, which list is it going to iterate through? It's going to iterate through staff rates. Set percentage to staff rates, and that's where your index position number is going to go. So percentage will start the first one time through. It'll be percentage will be staff rates 0, so the first item in the list divided by 100. So the first time through it will be 105 divided by 100. Needed staff becomes current count multiplied by the percentage. So you're starting with and then we've got send, week, and I, and needs, and to display. So that's our for loop. Okay. So we've read that. We've got an understanding of what that's all about. We will look at the question, and it is our programming construct question, and you want to be getting all of these right. Okay. I'll forgive you for not getting the last one right this time, but we'll talk you through that one, and we will make sure that you don't lose marks on these. You've got to know these, guys. These are easy points. 4 marks. Okay, we need these. You need these. So programmers use basic programming constructs when they write code. So these are our loops and our functions and our comments and selection, iteration, all of those things. Complete the table to identify line, number, or numbers. Okay, really important. Okay, we've got to get that. Some of you lost marks by not putting the full numbers for the construct. They illustrate an example of different programming constructs. A condition-controlled loop. Now, there are two loops in our pseudocode. We identified them as we went through. There's a for loop at the bottom, and there is a while loop here. Now, a condition-controlled loop is a loop that runs until a condition is met, and a for loop is a loop that runs for a set number of times. So the for loop runs 6 times from 0 to 5, whereas the while loop runs until good input becomes true. So while good input is equal to false, this will keep running. So it's the while loop that is a condition-controlled loop. It starts at 8 and it ends at 18, where you've got this end while. And this is a classic example of where you have to write the line numbers. Okay, you've got to write the start and end numbers. Some of you wrote every single line number, 8, 9, 10, 11, etc., and you get the mark for that. But 8 to 18 is enough. Okay, you don't have to list every line number, but if you want to, you can. But you must do that. It's a range. Comments. There were 3 comments in the pseudocode. One person wrote line 1. And I had to give it as a wrong answer. Line 2, okay? Just, I know you meant this, the first line, but you didn't write that. If you'd written first line, I might have given it, but use the line numbers. 2, 7, or 20. Alright, so 2, 7, or 20. Many of you wrote them all, and that's fine. In fact, why not? But you only have to write 1 in that case, because it says that you have to give an example of. Okay, so that's that. A selection construct. Again, this is so from the wrap selection. Got to make a choice, make a selection. If I get it wrong, it's in the wrong direction. Else life is sweet. So selection is your ifs, else, etc. If and else, if and else. So find where if and else, if and else. But in pseudocode, remember, there'll be an end if. So it's 12 to 17. A few people put 12 to 14, but that didn't work. Some people put 12 to 15, that didn't work. 12 to 16 I think you might just about get away with, but really look for the end if, where there's an end while and an end for, because that's the end of the construct. So 12 to 17 is the answer. 12 to 17 is the answer. Now, the subprogram call. I think you can be forgiven for being confused about that and not getting that, although many of you did, so well done. But when we've talked about subprograms, we have always talked about us setting up a procedure or a function, defining it in this way, so def, menu, open close brackets, colon, and then putting the code inside. Or we might have had def area, and then inside we might bring in height and height. How do you get height? Width. So we've always set that up, and when we do a function call, we would call menu, and we would do that menu, open close brackets. We would go area, and we would write height, width, or something. We pass in some values too. So it's always been about the name of the function followed by the brackets, sometimes with something in, sometimes without. And some of you wrote on the paper, but there isn't a subprogram call in this pseudocode, and you were right if you were thinking about it from the way that we've always talked about it. But actually there are inbuilt functions in Python or in programming where the code that sits within the function is hidden. And I think we have talked about particularly len as being a function. So len, when we talk about len, we would go, if we were writing this in Python, it'd be len week number. That's how we would be running that function. So the name of the function followed by the brackets and something inside it, and we would expect that to return a number. Now if you think about that, what's happening behind len is that it is iterating counting through the list to count how many elements there are in the list. So it's essentially a for loop and returns us the number, but we don't have to write the for loop, we just run the function. So there are inbuilt functions, inbuilt subprograms within programming languages that exist already with code behind them, which just simplifies the programmer's life. Now, the other examples of these, which we've never thought about probably as functions, would be print, because that is your basic code for a print statement. Print, open, close brackets, but we tend to, we would print. So this is an inbuilt subprogram. Okay, so print is one, input is one as well. So input, and you can see the open close brackets. So you can see the similarities. It's just that we have perhaps never actually thought about it in those terms before, and I think probably the only time I've mentioned the word function in terms of these inbuilt commands would be with len. So you're definitely forgiven for not getting that one right, but we won't fall for that trick again. So there were plenty of examples actually in here. We had here 9 where you've got a print statement, 10 when you've got an input, 14 is a print statement, 16 is a print statement, and len, which actually many of you picked, so that was good. Len there at 21, 24 you've got there as a print statement again. So just to show you that in the mark scheme. In this instance they did give 8, okay, but I can tell you that in the examiner's report it definitely suggests that you are reminded to show the full understanding. Identification of the full block is required, not just the first keyword. So I would expect that in the future, remember this was the first time round, that they won't be giving that, and in fact they didn't give it for the selection, so I'm not entirely sure why they gave it for the while. Comments there, and then you see there were actually 1, 2, 3, 4, 5, 6 subprogram calls. So that is question 3A, your programming construct.